Okay, here we go. So what I wanted to do is I wanted to start by looking at simulation software that I use. So I use a product by Texas Instruments. It's called Tina TI, and it's old, right? It's free. You can still get it. You can still download it, and I'll leave a link. But I've been using this for years, and it's really good. So let's go through this, right? So this is the entire inverter, okay? And I'll start with the PWM modulation. So what I do is I have a 60 hertz sine wave set up for plus or minus half a volt. And then I set up this function to basically take the absolute value of the input. And then that's what comes out. So this comes in, you get half volt, half sine coming out. Then I have a 36 kilohertz ramp that I set up at 1 volt. Okay, so a half volt coming in at a 1 volt ramp will give me a 50% duty cycle modulation. Okay, I use this 3016 as a high speed comparator, okay, which puts out 4.8 volts, 0 to 4.8. Okay, so it does the comparison, you get the PWM signal, and then what I do is I go through this voltage control amplifier here, or voltage control function, and it just takes VN, multiplies it by 2.4. Okay, so I come out with 12 volts. And then I feed through 10 ohm resistors to the gate of the FDP 26 and 40s, which are part of the library for this application. And so then I build up the transformer. So I have an ideal transformer here that just has a 3.3 to 1 ratio. Okay, you put the primary inductance across it. Okay, and then the known leakage inductance. And then this resistor that I put across it is basically to give it to dampen the Q, because if you just leave this as a pure inductance, the Q is immensely high. So what's going to happen is it's going to ring and ring and ring and ring, and it's not going to be real world when you run the simulation. So you have to dampen it, because in reality, the Q is not going to be that high. Even though you have the leakage inductance, the Q is low. And I'll go through that later on how I came up with 200 ohms. So it's really straightforward. Then I have the ability, I put a switch here to be able to turn on and off the snubber. Okay, so I have the snubber circuit here. Okay, I have my input power source with the input filter cap. Okay, then on the secondary of the transformer, again, it's set up in flyback. So the polarity dots are here. So that's why ground is up here and the diode is down here. So now that's going to work in a flyback mode, where when the inductor is charging, no current will flow through the secondary. It's only when the current collapses into the transformer that current will flow. Okay, and then I'm using these MUR 190s to simulate the diodes that I'm using. They're close enough. They're basically high-speed diodes. They're 1 amp, high voltage, fast reverse recovery type. Here's the output cap, 2.2 microfarads or 200 nanofarads, and then my 20 millihenry inductor here. Okay, and I basically come into this bridge. I just built this bridge using these voltage controlled switches, where I set up the on resistance to be 500 milliohms. And this emulates pretty well the 4-FET bridge, because at 60 cycles, the MOSFET acts as a perfect switch. And it's being fed, again, by a 60 cycle square wave, which you can select, right? And so it's square wave function. It's set to a half a volt, and then with a half a volt offset. So it goes from 0 to 1 volt. Okay, and then what I do is I just have another one of these functions, where basically I come in and I just say if N1, voltage in, is equal to 1, then make it 0, else make it 1. So it gives it an inversion, 180-degree inversion here. So I get my 2 driving signals. So these 2 switches opposite each other drive. So So this one is on, these two are on when these two are off, and then vice versa. So that gives me my bridge, and then I can measure my output current, my voltage, and then again I have another switch out here which allows me to switch between the grid or the resistance, just to show you both. So this is basically the whole setup. So what I'm going to do is to run this, I'm going to run one full cycle, right? If I set that up and use initial conditions, okay? And then what's going to happen, this takes about 4 minutes to run. So what I'll do is I'll run a whole bunch of stuff, and then I'll just go through the completed simulations one by one, and then we can kind of talk about everything.